Okay, so like I said, we're not doing anything new except after you take your derivative, we're just going to take the derivative again, and then we'll take the derivative again. So it's like getting a new question every time, okay? And when we get into the next unit, you'll start to see how when you take the derivative of the distance formula, you get instantaneous velocity, and if you take the derivative of that, you get instantaneous acceleration, all that stuff, right? So it actually does apply, and you're not often going to have to go to 5 derivatives or 10 derivatives like you may today, but the process that you do every time will be the same. Okay, so when you take the derivative of f prime, or a derivative of a derivative, that is called the second derivative. And if it had 1 prime before, we're going to give it 2 now. Okay. And that can also be done as dy, or d squared y over dx squared, or without the bracket, d squared y over dx squared. So the third derivative would be d cubed y over d, as you can see here, dx cubed. Therefore, if you're doing y to the n, that would be d n y over dx to the n. Okay, list the first 5 derivatives of x to the 4 plus 2x cubed minus x squared plus 4x. You're going to see now how these aren't difficult. You just got to make sure if you do the first derivative wrong, the 5th derivative is going to be wrong. Okay, so they have that. It depends what kind of mood I'm in. How nice you've been to me, like that all comes into. No, it's not about the math. So y prime. Okay, let's go quick on this one. What would be the derivative of this? Six x squared minus 2x plus 4. Okay, so y double prime is, we get 12x squared plus 12x minus 2. The third derivative would be 24x plus 12. The fourth derivative would be 24. And the 5th derivative would be, what's the slope of 24? 0. So yeah, you are finding the slope of the slope of the slope of the slope. Okay, now how would you tackle 2? Now 2, you can use the quotient law if you're crazy and love doing lots of complicated work, or I would just get everything to negative exponents, then do it that way all the way through. So we should probably write it as negative exponents first. So that's 4 minus x to the negative 1 plus 2x to the negative 2 minus 3x to the negative 3. Okay, so first derivative. What happens to that? 4? It's gone, right? And then the negative 1 is coming, so it's going to be 1x to the negative 2. We always want to lessen 1 up top, right? Take 1 away. And the next one would be minus 4x to the negative 3 plus 9x to the negative 4. For this one, we're just going to find the first three. The second derivative. What's the next one going to be? Negative 2x to the negative 3 plus 12x to the negative 4 minus 36x to the negative 5. Okay. The third derivative would be 6x to the negative 4 minus 48x to the negative 5 plus 180x to the negative 6. And since they gave it in the form of no negative exponents, we want to leave it in the form of no negative exponents. So that would be 6 over x to the 4 minus 48 over x to the 5 plus 180 over x to the 6. So it sounds a lot harder than it is, but when we get to number 4, you'll see that it is as hard as it sounds. Find the second derivative of this one. What's going on in this one that we're going to need to do different than the other two? What rule? The chain rule, because this is 1 plus 2x to the half. So to do the first derivative of this would be 1/2 1 plus 2x to the negative half, all times 2, which would equal, so this is y prime, 1 plus 2x to the negative half, because 2 times a half makes 1. How's that look? Okay? Now let's do a second derivative. The negative half is coming down. And then I will have 1 plus 2x to the exponent. I want a minus 2 over 2. 3 over 2 times 2, which equals negative 1 plus 2x to the negative 3 over 2. Because they did give it to us in radical form, we should leave it in that way. So I'm just going to put it first as a positive exponent. Right? And then that would be negative 1 over 1 plus square root of 1 plus 2x cubed. Again, I could put that 3 on the outside or on the inside. Okay? So up to now, not so bad. But what's going on in number 4 that's different than the other examples? You can't isolate y, therefore I need to do implicit, right? So let's just write that here. Implicit. Okay. And one thing that always occurs with implicit, because we're going to do 2 of them, you'll see as we do them that are very different than when they were just y equals, when you could isolate y. So let's just do the derivative. This would be 3x squared plus 3y squared times y prime equals 0. Okay, what do we always need to do? Isolate y prime. So 3y squared y prime equals negative 3x squared y prime equals negative 3x squared over 3y squared, which would equal negative x squared over y squared. I want you to just put a box around this. Or if you even really, we could even put this to okay, that's going to be important. Okay, to do the second derivative, we need to use the quotient rule. Well, we don't need to use the quotient rule. You never really need to, but we got a test coming up on Tuesday or Wednesday. Let's do a quotient rule. You can, but I just want to practice the quotient rule just so we still getting it, right? So we got y double prime equals. So now you can, remember, if you have a numerical coefficient in the front, you can take that out. So we have that negative sign. We can take it out. If there was a 3 there, you could take out the 3. But just make sure you're aware of it, that it's out there. Now remember, it's low, d high, minus high, d low, which is 2y, y prime, all over low squared. Okay, let's just kind of get some stuff together here, or just make it a little neater. Just in alphabetical order, that's 2xy squared. And then 2x squared y, y prime, all over y to the 4. You don't have to, right? Because actually, you could even do that, right, if you had to, right? But we're not done yet. Do you see anything we can do? Yep. Oh, it's supposed to be right there. Yeah, we could factor out. We'd factor out 2x up top, right? Or 2xy. And then there'd be some y's to cancel, right? There's also one other thing. If they gave me a point right now, could I find the value of the second derivative? Because I have y prime. But do I know what y prime is? Right there. Okay? And that's why I put that around it. So whenever you do implicit differentiation, you will have to always do a substitution step. And when you get a y double prime, or when you do y to the third derivative, there's going to be a double prime in there that you're going to have to shove this into. Okay? So I know what you're thinking. Good times is what you're thinking. So the other, if you do want to make your life a little bit easier, you could make this y prime equals negative x squared y to the negative 2. Okay, so what we're going to do is we're going to take that and we're going to put it right into there. So we got y double prime equals negative 2xy squared minus 2x squared y times negative x squared y negative 2 all over y to the 4. And we've got our negative sign there. Remember, we said now we can take out a negative. We could have done this before. Negative 2. Oops. There's the negative there already. Sorry. 2x y oh, here. No. Before we factor, we should do something with this mess here. So let's just get that factored one more time. That would be 2x squared y squared minus, we've got 2. What happens to the, oh sorry, that should be plus 2. X to the 4, y to the negative 1, all over y to the 4. Okay, now we can factor out. Sorry. Okay, so now that equals negative. Now we can take out a 2. We can take out an x. How much? What y should we take out? Y to the negative 1, leaving me with, what's y to the 2 minus the negative 1 is y to the 3, and then plus x cubed all over y to the 4. Now since we got a y to the negative 1 up top, we can bring that down below, and that would be y to the 1. So that would be negative 2, x to the negative 1. Sorry, x, and then y cubed plus x cubed all over y to the 5. This would equal negative 2x times 6 over y to the 5. Tricky, hey? So then you multiply the 6 in. Negative 12x over y to the 5. Who would have guessed? You guys don't sound like you appreciate that question very much. Okay? So this is a really good example to show you how even if it was a multiple choice question, that'd be a very hard multiple choice question. I don't have chocolate bar, but I've got something else. I already knew about that coming up. I think I got a bag of Skittles for you. No, for the homework. No. Well, okay. Now that you've seen one of these, let's just do one more so you have two good examples in your notes. Okay, let's do y prime. Let's do the first derivative. We ready? Okay, so what? Let's start pretty far to the left because these take a bit of room. So this is 2x minus, now we've got to do the chain rule here, so let's put the minus sign out front, like that, and it is the first times the derivative of the second plus the second times the derivative of the first, which is 1, and then plus 2y times y prime equals 0. So you guys have already kind of experienced how in that first, in question 4, just look for the 2 substitution steps. The same thing here. After we do the next derivative, there's going to be a y prime to substitute. And then, hey, just check, can I substitute the question in there? Because it all equals 3, right? So these are contrived, right? After 2 of these, they're not going to seem like something that you would have never thought to do anymore because you've already experienced it happen twice. I'm sure it would continue every other time. So we want to get y prime by itself. Right, so let's get let's get some stuff together here first. I'm just going to actually get rid of the brackets there. That's y prime, yep. Minus y plus 2y, y prime equals 0. Okay, so I got that y prime. I've got, on the other side, I'm going to put the minus 2x to get rid of that, and the plus y. And then I have 2y, y prime, minus x, y prime. Now, of course, I could have put negative x, y prime. It doesn't matter the order. It's just I like to have the positive one first. Okay, then I'm going to take out the y prime here, leaving me with 2y minus x equals negative 2x plus y. So y prime equals negative 2x plus y. And then over 2y minus x. Now, the reason I'm going to put an or here, just because I want you to be able to remember that substitution step, just make sure that you still identify this would be the same thing as y minus 2x over 2y minus x, right? It's the same thing. All I did was change the order of these two, but when you're looking for that substitution step, and maybe it looks just like this, but you're like, oh, that's not mine, I can't substitute it. Just remember these two are the same, right? Okay, so this one would be easier to do the quotient law on it too, so we'll do y double prime equals. So we've got low 2y minus x times the derivative of the high. So that would be y prime minus 2. Quotient. Okay. Okay, minus high, which is y minus 2x. And then d low would be 2y prime minus 1 all over 2y minus x all squared. Okay, we have no choice. We do have to FOIL the top, FOIL the bottom. Remember that negative sign also has to go into that set of brackets. So we've got 2y, y prime, okay, minus 4y minus x, y prime, plus 2x. Okay, so I'm going to bring the minus sign in and do the FOIL at the same time. Just skip a step here. So this would be minus 2y, y prime, minus y, should be plus y, yep. And then plus 4x, y prime, okay, I got 3 negatives going here, so that's minus 2x. That's all over my good old 2y minus x squared. Oh yeah, I shouldn't. That y is not supposed to be there. I really need to make my notes bigger. Okay, so y double prime. Let's get rid of some stuff. I got a 2y, y prime here, minus this one. No, because it's 3 negatives, so minus, minus, minus. Okay. Then I got minus 4y minus x. I can't get rid of that. I can get this positive 2x, and that negative 2x is gone. Okay, so we get negative 4y plus y gives me negative 3y. I put these two together. And then I've got a minus xy prime and a 4xy prime, so that is plus 3xy prime all over 2y minus x squared. Okay, guess what's coming? Got to substitute y prime into that. Yeah, if you guys want it, we can factor out a 3 first. I don't know if it's going to make it any cleaner, but it makes you guys happy. So what do you want to take out a negative 3? Sure, we got y minus 3xy prime. Oh, took that out. Oh, should be plus, no, minus 2y minus x. Yeah. It is a lot of pressure. Yeah. I do. I just have to. Okay, so you guys got this figured out yet? equals negative 3 y minus x, and then we're going to put in this baby right here. So maybe draw an arrow so you later when you look at these notes you're going to be like, how do we put that in there? Over 2y minus x all over 2y minus x squared. Okay, now this one, see I kept my 3 in, so let's, yeah, we do want to do a common denominator. And actually, you're going to see how it's going to cancel nicely with the bottom. So we have negative 3. So this is going to be y times 2y minus x over 2y minus x. Okay, minus x times y minus 2x over 2y minus x all over 2y minus x squared. So since everybody has one of these on the bottom, we can cancel that, and just put a 1 there. Okay, now I can see why I didn't take out the negative 3 before, because we're still going to have to do some factoring. But anyway, let's get the top all. That's 2y squared. Is there a mistake? Well, yeah, but I need to be able to add these or subtract these two together. I need to find a common denominator. Okay, so 2y squared minus yx, and then this is going to be minus xy plus 2x squared all over 2y minus x. Okay, again, correct me if you see anything I did wrong there. Okay, now this is negative 3. This would be 2y squared minus 2xy plus 2x squared. I just got those two together over 2y minus x. Well, yeah, it is. When you have that 1 comes down here, okay? So when you have 3 over 2 divided by 5, that's the same thing as 3 over 2 times 5. Okay? So that 2 can just come down to that lower level. So now what can we take out of the top? So that's why I didn't factor twice. So we just put in an extra step. It doesn't matter, right? But then you can now bring out a 2. So you'll have a negative 6. And then you'll have y squared minus xy plus x squared all over 2y minus x. So basically, when you can't go anymore, I took out a 2 and multiplied it to here. Now, if you can't go anymore, look back at your original equation. What does it all equal? 3. So this is negative 6 times 3 all over 2y minus x. Okay, and then I multiply by negative 18 over 2y minus x. Now, I did something here too. Can you see, can we go any more? Are we done? I think we're done too. I did something else for some reason later, but why did I do that? Oh no, just a sec. Yeah, there. Two y. Because I want to check that one step that you're talking about. Because I notice now that because that would have been. So this would have been divided by 2y minus x squared, which is the same thing as times. Oops. Right. So you're right about that step. Yeah. So this should have been, since we would have multiplied this all out, this would have been cubed there. Okay. It's good. How come, if you saw that, why didn't you say something? Okay. Me too. So that should have been just cubed all the way down. Just have to put cubed around there. That's because Mr. Suderman interrupted me in the middle of that question. Just made me forget something. Okay, there it is. No, that's as hard as they're going to get.